compression. I don't know why you guys enrolled to this subject. I guess maybe because of you're running out of advanced subjects to enroll or something, because data compression doesn't sound very sexy to me. Maybe it sounds very sexy to you, but really, people are here for different reasons, I guess. The main reason is like you have no choice. There should be, this lecture theater should hold at most 150 students, but we definitely have more than 150 students enrolled. So the good thing is like usually students will not attend all the lectures. So it should be just fit. If not, you guys are going to practice the compression 101, the physical compression, and see how we can fit all the people in this lecture theater. I don't know how we can fit, because really, for the fire hazard, we can only fit 150 students, but as well as I calculate, I think we have more than 170 students here. It's not hard. We only require compression ratio of like cutting 10% or 20% people. If we can stack them up, it will fit. Otherwise, we need to start some compression here, or move to the center, or someone can, the newcomer, just find an empty slot. We call this defragmentation. So the subject is, we are going to go through a few things, but really this is the real aims of the subject. So we'll cover, the buzzword here is, you like it, it's called foundations. Means like we only go through the foundations. We are not going to dip into too detail, but mainly the foundations of it. How different compression tools work, like your gzip or normal zip and so on. How do they work? How to manage large amount of data on small devices, primarily mobile devices. So if you want to develop an app that needs to host lots of offline data within the app, then this is the right course to tell you how you can squeeze lots of data into a tiny device and lab, and yet it still functions efficiently. And we will also go through how you can search large amount of data, primarily like at least gigabytes and so on. What's the techniques involved to search them? And how to perform search efficiently without adding too much index or indexing. So one of the difference between this course and if you're doing the other information retrieval course, they will be more focused on maybe the precision and recall, how accurate is your search result. They may mention a little bit about efficiency, but efficiency is a primary subject of this course. And then how we are going to query data when we talk about web search or web data compression. Web data, they are normally not centralized. Web data, intrinsically, they are distributed. So how you can query those distributed data. So for example, if I have a large database, and let's say I'm Amex, I have some data in US, some data in Europe, some data in Sydney, and let's say I want to query all these distributed data repositories, how I can efficiently query those data without knowing where they are, and yet I don't need to run the world for each repository. I need to post the same query until I find the answer. What are the smart ways we can do that? If we have time, that will be the optional topic of that. Not because of it's related to data compression or web search, but because of web data, primarily they are distributed. So if we have time, we will cover that as well. All right, so the first page is really the aim. The second page is for, I guess, for the policy or whatever, we are supposed to discuss the course aims in your first lecture. It's a boring bit. You can actually find it from the course outline. But essentially, the course is going to introduce you the concepts, theories, and the algorithmic aspects of the data compression and the web search. So we will introduce you more or less sort of the recent development in various areas of this web data optimization topics, common practice, and some applications. Now, later in the subject, when we talk about web data, we will assume the web data do not include exciting stuff such as video or images. Although these days web data, normally we talk about their images and video, but they will be a different focus. You can find other courses that hopefully will cover those topics. We are focusing on text or the content of the web data, textual content of it. We assume they are more or less in XML format, which will cover HTML or RSS feed, atom, JSON format, web messages, and so on. We assume they can easily model in XML anyway, so it's not a big deal here, the formatting. And the most important thing is we will learn, and you will learn lots of tricks how you can search and retrieve this information quite quickly, and yet we can compress the information. You can find all this information from the course web page. In case you don't know where's the course web page, I doubt it, otherwise you probably wouldn't be here. But this is the link for the course web page, and this is the lecture time in case you don't know. And the lecture is from week 1 to week 12, and I have the consultation hour right before the lecture. So it's very convenient. If you want to see me, you can see me before every lecture. I'm your lecturer in charge. I don't want to be in charge, but somehow I'm your lecturer. So you can find me in the level 2 of K17. Get out of the lift, turn right, you'll see me. It's not in a secure area, so it's easy to find. Secure area is two ways. It's secure you, it's secure me. It depends on how you see it. But I'm pretty open, so it's not in a secure area. You can email me, you can call me, but ideally you email me is better. When I'm not in office, I won't pick up my call. When I'm in office, I don't pick up my call either. So I think the ideal way is just email me. I mean, it sounds like a joke, but when I'm in office, I'm always in meeting, so I won't pick up a call. When I'm not in office, of course, I can't pick up the call. So basically, email is really the best way. Of course, otherwise, for the subject, you can always do the forum and consultation hour and so on. But it's just phone these days. We hardly use landline. Do you use landline? I don't. We have a course tutor. We don't have tutorial, but we have a tutor. The tutor is available every week from next week onward, Wednesday, Friday. So if I cover Thursday, so you basically have Wednesday, Thursday, Friday cover with consultation. So in case of you have any questions regarding the lectures, assignments, you will have anyway. You can come to see us on Wednesday, Thursday, Friday, and we'll be level 2, K17. And you can also email him if needed. The lecture is basically focusing on the understanding of the compression and the search techniques, which I'm going to talk a little bit more detail what they are about. And we try to run in more interactive mode. Other than just me talking, I will try to get you to participate in some discussions and so on. A few lectures may run in more practical manner, such as almost like a lab or demo to cover various aspects of the topics. So when you guys finish this subject, if you're interested, you can email me and you want to be a tutor, you're more than happy to be a tutor. We always run out of tutors. One of the reasons there are some hardcore topics on these subjects, and your lecturer in charge, which is me, sometimes a bit picky. I don't pick every tutors. If they are not competent enough in those topics, I'd rather have no tutors. So I don't like the fact that if you have multiple tutorials, if you go to one tutorial, you learn more, you go to another one, you learn less, and that will create the inconsistency. And that inconsistency in a hardcore topic such as this one, it creates lots of issues, especially if the tutorial is about assignment. And if one tutor tells you the wrong way to tackle the assignment, you'll be very upset when you receive your marks. And if that's the case, I'd rather we all receive the same thing, whether it's enough or not, at least it's a fair ground. So I will use a lecture from time to time to run it almost like a semi-tutorial in a sense that to demonstrate something, to answer some questions and so on. At least you have one venue and one interface to deal with that. It's not, every year is not the same. Last year we have a tutorial, the year before we don't have a tutorial, because last year I got a tutor who got full marks from previous year. And so he's probably better than me in that case, like if the inconsistency or the weakness will become from the lecturer, not from the tutor, because the tutor better than lecturer. But it's not every year like that. So this year I didn't find one. So if that's the case, then I run the tutorial instead. But as I said, if you do achieve close to full marks this time, you're welcome to drop me an email in a subsequent, I don't know, even you are getting a job. I do have a tutor, I think 2 years ago. He's actually working full-time, but he did the course a few years ago, and he actually got very good marks, so he was a tutor as well. So it depends on your interest. Sometimes it's quite fun to give students hard assignments. I just say sometimes, so you don't need to be panicked right now. Again, for those of you guys probably attend some of the courses I taught before, I do like to run the lecture according to the content. I mean, so some lecture may be quite short, some lecture may be quite long. Long means like not over time, but close to the dot. It depends on the progress of the content. So if I think that we finish a topic, I rather finish a topic and you can enjoy your early supper than to start the new topic just 5% and make it become a cliffhanger until next week. That's just like useless. And some other time you'll find that like maybe from this lecture, next lecture, sometimes I talk too fast. Maybe I try to finish the whole course in one lecture. And if that's the case, I will try to stop myself and stop talking and let you talk. If you have nothing to talk, I have nothing to talk, then we can all go back and enjoy our life. So lecture length varies depending on the progress, and we will see how it goes from time to time. I will ask you guys and we'll see. Now, one thing I assume is like because of the way we run the lecture, and that's why you wonder why this course is not running in web stream mode. There are lots of students asked me before why we are not running in a web stream mode. The web stream is very good to capture the lecture, the slides, and me talking, but it's not very good to capture you talking. So it's very hard to capture if we run the lecture sometime in an interactive mode like a tutorial. We videotape the lecture. We don't videotape the tutorial for that reason. Otherwise, the lecture need to repeat all the questions the student asks again and then answer, like a spokeslady of Donald Trump. So I don't want to do that. I repeat the question, who asked the question, and then you next. I don't want to do that. I want to focus on the interaction between the student and the lecturer. So it means like, hopefully you can attend most of the lectures. We will provide you some exercise from time to time. Probably every 2 weeks, there will be some exercise online. And then 2 weeks later, I will post a solution there. And also from time to time in the lecture, I will select those difficult questions and solution and go through in the lecture. So more or less, it's almost running in a whole class tutorial mode in that sense. And the exercise is, the primary focus of the exercise is to prepare you for the assignment and for the final exam. So the exercise will be helpful for your assignment and will be extremely helpful for your exam. So you can assume this is tips or hints. Extremely helpful for the exam. That's the buzzword. There's still some empty seats there. We don't need to run compression yet, so you guys can find an empty seat. Yeah, so that's about exercise. And the best thing about exercise, like, they are not accessible. So, I mean, no assessment. So it's not contribute to any marks. You don't do it, that's fine. But they're helpful for your exam and assignment. Another good thing about this subject is no textbook, so you can save your money. Slides will be provided, and they are free. And you can get the slides from the course homepage. Course readings, papers, primarily they are from the original research papers of those topics. They are provided. As well as you enroll to this subject, you can also download from the course website as well. So for example, this week, you'll find 2 papers there for you to download. Some students ask me, like, in the past, they found that some of the papers are very hard to read. They are not in English. They're in English, but there are more Greek symbols in the papers than English words in the paper. If you understand all the lecture content, you can safely skip all the paper. You don't actually read them at all, because I will explain all of them in the lecture slides. However, if you find that I don't really talk in any sense, you want to read the original content, to cover my bum, I do need to give you the papers and say that you do have the material. If you don't understand what I said, all the detailed examples are there. So they're there. But as I said, if you understand the lecture materials, you can safely not using those papers at all, and should be enough for you to cope with all the assignments and the final exam. But in case you miss 1 or 2 of the lectures, you find that by reading the video or watching the video is not good enough, the original material from the lectures are from those papers. So you have them. But as I warn you, they are harder to read than my lecture slides. But they're more detailed, for sure. There are some other references and supplementary materials that can be found from the course homepage, and from time to time, I may give you more if I find that you need more, or you ask me some question that I find that it's good that I give you more materials. But otherwise, these days, Google is great. You don't need the lecture to give you the pointers. You can always Google. Assume knowledge. Of course, you need to have some data structure courses or course that you have done before, such as 9024 or 2521. If you haven't done one, again, you shouldn't be here, because the system wouldn't let you. At the start of this course, we assume that you understand the fundamental of data structures, and you can produce correct programs in C and C++. I'm sorry that I need to highlight the word here is called correct, because there are many students that say that, like, I know how to do C or C++ programming, just don't know how to make it correct. So correct is a buzzword here. They do, sometimes when they submit an assignment, they do submit assignment to me in C or C++. It's just not correct. So make sure you know how to do a correct C or C++ programming. That including the program can be compiled correctly, can be run correctly according to the spec, and you test it, and you know how to debug. You may find that, like, wow, this is like, is it a legal contract? No. The first year when I ran this subject, which is like, I think 6 years ago, because it's a brand new subject 6 years ago. So it wasn't as developed and not as rigorous, those statements, and end up like the tutors and myself end in tears. Essentially, your student come to your office, ask me how to run the debugger. This is not a programming subject. So then later I learned, yeah, I need to put that as a requirement. They need to know how to debug. And later they find that, okay, they know how to debug, but they don't test. So I need to say, oh, they need to know how to test. So, and hence it become longer and longer. I guess if I find some problem this year, I will add it into the buzzword, and it will become even longer. Produce a code that's readable, not full of the variable called I1, I2, I3, I4. So something more readable, please. That would be great. And some documentation will be much appreciated. And you also need to know how to do some abstraction in computing, abstract the problem. Learning outcome, this is what you expect after you finish this subject. So you have a good understanding of text compression. In fact, we can fulfill the first bullet point after the first 2 weeks. We can cover all the text compression in 2 weeks, if it's not today. And then we introduce you to more advanced compression techniques, such as, which is quite a core of this subject called BWT, which is a fascinating compression technique that you learn from this subject. Some of the past students, I still have some good contact with some of the previous students, and they find that maybe half of the subject is actually about this BWT. In some sense, it's true. It's a beautiful algorithm. It's actually quite effective as well. And you probably learn that after 2 weeks. In week 3, you learn the algorithm. It's actually quite amazing. You will see some example later today. You will gain some programming experience in data compression and optimization, and have much deeper understanding of XML and some XML processing optimization. When I say XML, I mean web data, web text data. And understand the advantages and disadvantages of data compression for web search. When should you compress? When you shouldn't compress? Not always just turn on the HTTP header to compression. Your performance is always better. It's not necessarily the case. Depends on your applications. So after this subject, you understand the trade-off, when you should compress, when you shouldn't for web data. And the basic understanding, as I said, of the web distributed query. When you try to query the web data that is distributed over different geographic locations, how you can query them efficiently. And finally, hopefully you can appreciate the past, the present, and the future of data compression and web data optimization. That's the outcome. This is a slide that you concern the most. It's called assessment. So you will start with, well, the good thing about that is like totally only 2 assignments and 1 exam. So pretty light in terms of the number count. Except that first assignment supposed to be easy, supposed to be. But I used to be called, that's why 2 lines are not the same length. The first line used to be called 1 warm-up programming assignment. If you look at the lecture notes from last year, it say 1 warm-up programming assignment and 1 hardcore programming assignment. After a student accused me that not really warm-up lecturer, then I removed warm-up. So then you have 1 programming assignment and 1 hardcore programming assignment. If students like it, everything is relative. You study Einstein relativity, everything is relative. Whether hard or easy is relative. I can easily remove the warm-up. It doesn't mean that it's not warm-up. It doesn't mean that it's not hard either. It's just like hardcore will be harder than the first one. It doesn't mean the first one is easy. It's just hardcore is harder. So, and marks will be proportional. In fact, it's not proportional. In fact, I would say that like if my honest proportion of that, then the first one should be 30%, the second one should be 110. But because I want to make it the first one is warm-up, so although it shouldn't deserve 30 points, it may be 20 points or 15, but I give you 30 points because it's easy assignment, you should deserve to get more marks from an easy assignment. So that's the first one. So what it means is like if you find a first assignment, it's very, very difficult, you're in trouble. Maybe penalty for late assignment submission, 1% per hour. I want to do 1% per minute, but you'll kill me. So I think 1% per hour is good. And don't want to accept after 3 days. One of the reasons for that is like really like when students submit late, it because of the privacy reason, I can't announce who submitted late. Otherwise, I would, because the late submission will block the testing of everyone. I have the testing script the script that tests the performance of all assignments. I have to run in one go. So when it starts, it's very hard to pull out some and put it there and plug it. And it measures the memory consumption, the runtime resources consumption, the runtime, various time benchmarking of the function call and so on. It's really doing like benchmarking and compare. And so the sensible way to mark it is like if anyone submit late, I will wait for all the submission before I run it. And that's why I don't want to wait until too late, otherwise it will delay the announcement of the result. And that's not fair for those who submit on time. So hence we got this penalty scheme. On the other hand, things happen. So which means like if you only submit like, I don't know, 2 hours late, we're talking about 2%, it's nothing. So if you think that you need the extra 2 hours, go for it. But I think things will become more painful and bleeding if you submit more than 1 day late, because that's 24% gone. So, but as I said, don't aim for like, for the first assignment, I aim for submit 2 days late. That's just the wrong aim. But as I said, if things out of, accident happens, like modem broken, You run to your friend's house, running like 200 meters, I don't know, in your fastest speed, it shouldn't take an hour. And then submit from there, it's 1 hour late. So it's 1%, it's nothing. But as I said, that should accommodate for accidents, but not accommodate for intentional delay of submission, that you'll be penalized heavily in that sense. Now, from time to time, there's some crazy students, they say that hardcore programming assignment doesn't sound hardcore enough. I want a harder assignment. In that case, again, things is relative. You laugh now. We do have some students. Again, I will not announce their names in case they will be stoned by you guys. So you can come to see me secretly before week 4. You don't have to tell everyone that why you come to see me. You can just say that you come to see me to ask questions. But you can tell me that, in fact, you want a harder project. So if you do the harder project will be tailor-made and only one project instead of 2 assignments, and that's it. It's only for you. The only criteria I need to make is make sure you can suggest anything. As far as the project is about web data search and compression, and as far as the project will be harder than 2 assignments add together. I can tell you that. You tell me what you want to do, I can tell you whether it's harder or not. I can tell you the statistics. On average, every year, it's about 2 students doing that project. I can tell you a sample project that is done last time. So they're doing exactly like the assignment, except that they're using GPU to do it. So they're doing parallel version of all the assignments using GPU. That's one of them, for example. Then you ask me whether it will be hard or not. Of course, I would say that, gut feeling is like you're doing exactly the same thing except on GPU, so it will be at least as difficult as that, plus the parallel processing part. So it would not be easier. So for that, yeah, go for it. But means it's a contract. I will send, I'm very good in a contractual agreement these days. I will send you an email then, and this is what we agree. If you can't do it, you'll be penalized. But if you do it, you'll get the same marks, probably bonus. Every assignment will have bonus. So as in I'm not sure about the first one. I'll take it back. The hardcore one definitely will be. So in case the first one too easy, then give out the bonus is not fair for the second assignment. So the hard assignment, every year we give bonus. Bonus means up to extra 10% of the score of the assignment we're given to. For example, sometimes we give to the fastest program of the whole class. Sometimes we give to the smallest program of the whole class, which is if the class is on average, every program using, let's say, 50 megabytes, for example. This one only use 8 megabytes. Wow, that deserves a prize. Not a free dinner, but I'm quite tight. So it's just extra 10%. But we'll mention in the spec, so it's not like something we design on spot or something. It will be in the assignment spec. So there'll be some extra reward scheme for that. So final exam, one final written exam, 100 points. And again, I remind a student every year, but sometimes, from time to time, there'll be one exception, they didn't do it. So do not attend the exam if you are not feeling well, and I will not accept any medical special consideration if you do actually attend the exam. So please do not attend the exam if you are feeling not well. But on the other hand, I do also recommend you, please attend the exam if you are feeling well. There are some students that they're actually feeling well, and they do not attend the exam, and then they find a medical certificate and so on. But it's not like you have the medical certificate, you will definitely grant it with the exam. It has to be approved by myself, and there'll be a committee to approve that for the final exam consideration. So make sure that if you have a legit reason, don't attend the exam and attend for the final exam, the sub-exam. Otherwise, go for the final exam. The final marks will be based on the harmonic mean, which is you can't do it too bad on one of the components. We started doing that since, the other subject I did that too, but I started doing that since I think it's 2012, that when one of the students got extremely good score on the assignment, but not very good score from the exam, and later, luckily, I have a student working in another company, which is not very good for that company because I think he violated the privacy rule for that company, but I'm still very appreciate what he did, and he told me that my ex-student told me that, oh, you know, one of your students in the 9319, they hire people from our company called Freelancer to do your assignments, just to let you know, Raymond. So, okay, that's good to know that. So we find that we know why he did it really well. And apparently the market price for the assignment for this subject is pretty high. So as in, at that time I was thinking of, it's such a business model, right? So if a lecturer make the assignment extremely high, I wonder, right? The hourly rate is proportional to the difficulty of the assignment. So if I make an assignment that is almost impossible, then it may be I don't know, $2,000 per hour or something like that. It's really it's proportional. It's insane. So because we imagine what skill set you require for this subject? Oh, someone excellent in C or C++ programming can do low-level stuff, no data compression, no web search, no web data. And you need to write a program that fulfills some performance criteria. This is not going to be cheap. So it's a good one. So if you have a decent program, you want to save it for the future in case you can sell. But please, after you sell, let me know. So you take the money, I still catch the student. That's win-win. I think it's exactly the case. I believe that that company, freelancer, whatever, after you hire them, you still charge them because they've done the job. But after that, I caught you. It's just unfortunate, but it happened. So anyway, so this is what happened. So I also want to take this opportunity to say that means you shouldn't plagiarize because it's bad and you'll get caught. That's the external help for the plagiarism, and definitely you shouldn't do inside plagiarism, as in within the peers. It's very easy to detect. In the past, we caught students from time to time, but not many. I think is not because of our plagiarism detection mechanism is bad. It's just because of we have too many honest students that they would not plagiarize. Because it's relatively easy to detect plagiarism in this subject. If you have two programs, let's say we have some auto test to test the correctness. Let's say they are equally performed, two programs equally perform in the correctness test. Let's say out of 40 tests, both programs score 38 out of 40. And exactly wrong on the two tests, both programs exactly the same. Not just that, use exactly the same amount of memory. And also, in par in the runtime performance. And also, when I do the function call, the number of function, although the function call different name, everything, maybe have a more parent call and so on. But the stack, the trace, it looks similar patterns. You know what it means? Unless I close my eyes, otherwise, it really makes me that if I don't look at this, I should just resign because it's too much. It's really so obvious that if I show that chart to everyone, every of my colleagues, this is ridiculous. It's really like that. So in the past, I did print that out because we are doing that for performance checking anyway. We are doing that to find who should get bonus anyway. Since we are doing that, it's so easy to find the same. And if I share that with the tutor, I say, yeah, that is definitely. But we still invite the student and say, hey, can you explain this and so on. So as I said, you friendly discuss with your friends and students about solution and so on. That's fine within the limit that you're not, hey, this is my solution. Copy this line and that line. That's not fine. Yeah. So. Now, usually in the past, students fail the assignments because of plagiarize, usually. Or the program did not compile for various reasons. Most of the students, when they did not compile, I asked them, why did not compile? It would say that, oh, it compiled on my home machine. But I said that, why it didn't compile on a CSC machine? I said, I don't know. Then I said that. But I said that you will test it on a CSV machine. I said, we'll run out of time to test it. As I said, your program should at least compile. No compile, don't expect me to fix it such that it will compile. I will not fix it. Although I look at it, I know how to fix it. But I wouldn't fix it because that's your job, not mine. Mine is to test it, not to fix it. So should have at least compiled. You laugh right now. Every year, every time when I did this in a lecture, it's like that. And after the first assignment, I'm so looking forward to telling you how many cannot compile. Every year will be the same. And the funny thing is, no matter how hard I warn you in lecture 1, the ratio will not change. I don't understand why, but it just happened. So we always will have this kind of funny statistics in the course. Your program works on Windows, but not on Linux, although the spec clearly say that we test on Linux. But you will say that your program works perfectly fine on Windows. I'm sorry. We are not a friends of Bill Gates. So Linux, that's the test environment. And sometimes they fail, they got like, so try to do your assignment early because some of the solution, I really feel sorry for them. If I could, I would like to give them the marks, but I can't because it's almost like a contract. I said this is an assessment scheme. I have to stick with it for the fairness of the whole course and the other people. So the solution, I admire the solution, actually pretty good. Even have a chance maybe to get a bonus, but unfortunately it's something like 2 days late or something. It got heavily penalized. So it's just unnecessary. If you started maybe 2 days earlier, you will have a solution that have a chance to even win the bonus. So, but it's just because of the lateness. It's just a shame. Because when I look at it, I really feel painful for them too. Because when I look at the solution, it's pretty elegant. It's just run out of time. That's why I submitted late. So it's not worth it. Or program did not follow the spec. When I give you the assignment spec, I will mention again what it means. Like sometimes they just very, very bad in checking the spec. And usually program fail the auto marking. So I will give you some sample tests before. You just do a test with the sample test, then your program should be fine with the auto marking. We can avoid or reduce that. You just need to follow the sample test or the spec I gave it to you. You should be fine. Again, final warning before you make the worst decision of your life. Do not enroll to this subject if you're scared of the data structure course. Yes?
1927, does that count?
Is that data structure?
I think it's the same. It was. I was like,
Oh, it's the same. If it's, well, actually, if they let you enroll, I think it would be the same. Otherwise, they wouldn't. Yeah, they're stricter than me, so it should be fine. So as well as you're not scared of data structure, as I said, oh, hash table. No. Then you should be fine. Yeah. I mean, there are plenty of other subjects that say you do what you like, don't do what you don't like unless you hate yourself. So as I said, like if you don't like data structure, this subject will require some data structure, so make sure you actually like them. If you can't produce correct C++ program on your own, the buzzword here is on your own, by the way, don't do it. So if you have poor time management, you shouldn't do it either. If you're too busy to attend, no, you are too busy to attend lectures, means you have no time for me, don't do my subject. So, you know, as I said, we're all busy. So if you miss 1 or 2 lectures, it's not the end of the world. But if you enroll this subject with the intention that, like, I'm always busy on Thursday, I plan to just watch the video anyway, I don't think this is a good subject for you. You will, it's not like you definitely fail, but you suffer from disadvantage when the other student attend every lecture. That's all. So I don't think you should, you know, deserve those disadvantages. So make sure this is the right subject for you. So from the past experience, usually when I ask those students why you didn't do well and end up, of course, you know, sometimes they don't actually reply me because if they are not doing well, then they wouldn't reply. But some of them reply mainly is because of the above reasons. This is the tentative course schedule. I just copied from the course outline. week 1, this is what it is. And I aim to finish today is week 1, so I finished week 1. Probably we can finish a little bit from week 2 as well. We more or less can follow this schedule. If we are ahead, anytime when we are ahead, I will use those time to run more interactive tutorial. So that's how I do it. So whenever we are ahead, I can steal the time and ask you guys if you have any question. I can repeat some question and go into more detail. And there will be a dedicated revision on week 9, which is for the exercise question and answer and assignment question and answer. So almost like run the whole lecture as a tutorial. From my experience, you need that because the next week you have assignment due. The problem with that is like even some of you guys, you do not have the assignment questions on that lecture. The problem with that is like usually 1 week before the assignment due, attendance of the lecture drop below 10%, a single digit. So out of 100 students, I only have 10 in the lecture theater. It's not because of they hate me, they're just too busy on the assignment. So if that case, there's no point to go to a new hardcore material in the lecture when 99% or 90% of the students are not in the class. So I would rather run it as a tutorial. And guess what? I think started from 2 years ago. When I do that, attendance rate actually going up. In fact, on that week, I have more students because you are scared of missing out, maybe some hints, some tips for the assignment. So you actually will attend that lecture. Some of them I never met before. So I think it's a good way to have at least one lecture to meet all the students. That will be week 9, suppose. This is a long list. But as you can see, I like compression. So I'll compress this long list into a shorter list. So we summarize the schedule. Means like the first topic we'll cover in the whole course is called compression. So I will give you some idea this week and next week about basic compression. Then after that, we'll spend 1 lecture to talk about just search. Then after that, we'll spend 2 lectures on compression and search. Means like we compress the data. And you need to search the compressed data without decompressing. So if I give you 1 gigabyte of data, I want you to compress it into 200 megabytes. I want you to search that 200 byte data without blowing it up back to 1 gigabyte. Search it while it compressed and get the result. Now, in some situations, you have to do that. For example, at that time, I will demonstrate one of the apps. We did it, I think, 12 years ago. So 12 years ago, the whole Wikipedia, excluding images, is about 60 gigabyte text. So we have 60 gigabyte text. We're talking about 12 years ago. That is just 1 year before iPhone. So no Android yet. We are still using the Nokia. What's this called? I can't remember what's the OS called. S40? No. I can't remember what it's called. It's a proprietary Nokia operating system. Symbian. Yes, Symbian. That's what it's called. So you need to deal with, and there's no 4G at that time. Maximum is 3G and very shaky. So you have 60 gigabyte of text data. You want to put in a Nokia phone. And the Nokia phone, the maximum SD card you can accept at that time is 8 gigabyte. So we compress the 60 gigabyte into 8 gigabyte, and you want to do the search there. Any search mechanism require you to decompress it will not work because the whole SD card is only 8 gigabyte. Where you decompress it to? Nowhere. And also, if your program have to somehow load a big chunk of data into memory, it will die. There's not much memory on a Nokia phone at that time. At most, you can squeeze 10 megabyte. So you have 10 megabyte memory, 8 gigabyte SD card, 60 gigabyte data compressed, and somehow squeeze into that 8 gigabyte. I can tell you it's about 6.2 gigabyte. Just fit the SD card. And I want you to do search there. I want you to do full text search with the search time less than 0.1 second to produce the top 50 matches of the query. So now that is the skill we are talking about. I want you to have from this subject. Well, you don't need that to pass the course. I'm just saying that I aim for that. So as in aim for that. That's the goal of it. But you don't need that. As I said, we only cover the foundations of those. Those are not the foundation. Those are pretty advanced. Those are actually production level. But what it means is like the subject, why we call it like web data compression and search, they are not separate. They are not, we talk about compression and search. We are talking about together, compression and search, which means that you have too much data to fit in your devices. You want to make it smaller for the sake of smaller, such that it can be smaller to handle, faster to handle, and so on. We don't make it smaller, and when you use it, you need to decompress it, spend more time to do it, and then search. Then defeat the purpose. We want to keep in the same form so that you do it more efficiently. And finally, there will be some, so we start with the compression and search on the normal text data. Then we move on to the compression and search on the web data. The difference between the text data and web data have link. Web data also have a path. Text data, no, just flat. So that's the difference there. So when we talk about the web data compression and search, we talk about the path, the link, and the text. And finally, some selected advanced topics like graph data or distributed search and so on. That's the schedule. That's just the high-level summary of this 12 weeks of topics. All right, to start, questions to discuss means for you so that you can answer. We call this World Wide Web. Not really. It's a triple W. It's what, why, where. So what is data compression? Why do we need data compression? Where do you see data compression these days? You don't see data compression these days. They're hidden. It just happened behind the scene. But they're everywhere. But what is data compression? Anyone without picking the next slide? What is data compression? Anyone? Yes? Yes? Yeah?
Well, it's a method for basically storing a certain amount of information in a smaller amount of space, typically by working on the fact that the data is not entirely random. You look for some structure which you can exploit to represent it more compactly.
Pretty good. Pretty vigorous. Anyone else? Anyone else don't agree? Oh, you're pretty good. Like everyone agree with you. Okay, good. You should go for election or something. Everyone agree with you. Good. That's pretty good. So yes. So in a layman term, we try to minimize the amount of information to be stored and transmitted. It's exactly as what he said too. Like, and more technically is we are going to discuss for the rest of this lecture. We assume that you transform a sequence of characters into a new bit sequence. And we will see things in a bit level and see how they're being compressed. Now, hopefully, after you go through this transformation, the same information content will be preserved for at least what we call the lossless compression. In most of the discussion we have in this subject, we assume lossless. In some cases, we will allow lossy, but we will mention that first. So for the first few topics, we assume all we talk about is lossless, as in after you compress, the same information content is preserved in a compressed form. And during the transformation, you want to make sure the new bit sequence is as short as possible. So you actually reduce the amount of bit sequence to represent, the amount of bits to represent the same information. Now, some tools you are familiar with. If you're as old as me or older, you will know there's a big Z, that's from the Unix compressed tool. And there's some normal zip software from WinZip and so on. There's a gzip, there's a bzip tool, and there's some other tools that you can give you the file with all these extensions. This is the classic example I show to students why they need to study some fancy data compression. So suppose that I give you a piece of text, actually a string of this. So you can see this string. It's not quite readable, but it's quite neat. It's very, you can see some pattern there. This is the first compression technique you learn from this subject. It's called running coding. So the running coding essentially is a very widely used, it's actually used in many products. You have that. Although it's trivial, it's simple, but it's quite effective. It's the simplest compression algorithm you learn from this subject. It does not assume a memoryless source. If it's totally random, it's not effective. So you assume there's a memory, so it's not totally random. It replaces the runs of a symbol, possibly of length 1, with a pair of symbol and a run length. So for example, with this, I know that like A will be repeated 3 times, so I instead of repeat A 3 times, I just put A3 instead. So this is A 5 times, so I put A5 instead of repeating A 5 times. So by doing that, I'm saving the number of alphabets number of letters required for the original sequence. So this is just a running coding. Instead of repeating the symbols, I store the runs for the symbol. And it is a legit compression algorithm. It's just trivial, simple, but effective when you have lots of repeating patterns. Okay? Now, unfortunately, although it's effective, but in real world, you don't have many texts like this. In fact, in your assignment, you won't see many test cases like that either. That's too easy for you. So you will have more nasty cases such as this. Just to mock you, by the way. You see the pattern. It's just a pattern, not repeating. So you don't have all the A's together, all the B's together. In fact, then, except 2A here, I can see 2A there. You never have anything repeating more than twice anywhere. So means you can't replace anything. Even 2A, you make it become A2, it's still 2 letters. You're not saving anything. So if you're using running encoding here or running coding here, you're not saving anything. Okay? So, but this kind of thing happen a lot. This situation happen a lot. So then we need a new technique to do that. Now, if somehow I can make the first line become the second line, or the second line compared to the first line is nasty. You love the second line. Because with what you just learned, with the running coding, you just learned right here, it applies nicely to the second line, right? But not nice for the first line. You wish the first line is like the second line. Fortunately, we have an algorithm called BWT. It can map the first line become the second line. And then we can do the running encoding to compress it. So in week 3, or if we squeeze really hard, the end of week 2, if you can't wait, but I think you can wait, then it will be week 3. We'll talk about the algorithm. It's called BWT that will map easily the first line become the second line. In fact, the algorithm itself consists of 2 steps that will map the first line become the second line. And I can also do the 2 steps to make the second line back to the first line. Now, to make things even better, now that's week 3. I'll give you a preview. Then will be after week 3, there will be a week 4. But I told you, week 4 is like on search. we'll tell you how to search such that if I want to search for how many cap, C-A-B, in the original text, I can look at the second line and can tell you how many cap from the second line in constant time. You know what I mean by constant time? It means like if the second line is that long or 1 gigabyte long or 1 terabyte long, it takes the same amount of time to tell me how many CAB in these messages. That will be week 4 or 5. To make your second assignment hardcore, your assignment will be in this topic. We call this hardcore. So it means like you will have something encoded, compressed, and ask you to search, expect you to search in constant time. So whether the file I give you is 10 megabyte, 100 megabyte, 500 megabyte, it should take the similar amount of time. It will be. So, and that is BWT. And when we talk about that, you'll find that it's, I mean, even when I told you that it can be done, you say, oh yeah, good, pretty cool, huh? But when I tell you that it's actually very simple to get it done, it's only 2 steps. And the 2 steps are very simple. It's not like lots of equations. It's 2 simple steps, almost like 1 plus 1. Very simple steps. Then say, wow. And if you just memorize these 2 steps, it's very easy too. It's actually anyone who have done first-year computer science, it can do those 2 steps. It's not hard. It's not like theory. It's very easy. It's mechanical 2 steps. But to understand why these 2 steps will work, gosh, that's really hard. As I said, the 2 steps when I tell you, is that all? You say that. I can almost promise to you that your reaction in week 3, unless you cheat and you pick the lecture notes and you study beforehand, otherwise you say, wow, is that all? That will be your reaction. And after that, your reaction will be, why? You puzzle for days. But then I will let you puzzle for a week because I will only tell you 1 week later. So that is BWT. Let's have a break first. Then we resume the lecture. In case you guys want to eat, let's have a break for 10 minutes. Then we resume after 10 minutes. You can ask me in week 3. Okay. You can ask me in week 3 after we discuss it. Yeah, we will see. Week 3. Okay.
Hi, I was wondering if these lectures are recorded.
It should be recorded. Yeah.
Okay, cool, because I have a class now.
Yeah, it should be. But you should try to attend.
Yeah, definitely. So, yeah, thanks.
Yes. So usually what happens like, of course, I need to set it up first, but I can't set it up until the first video is there. there. So after tonight, when I receive the email, they say, okay, video has been recorded, then I can set there and put the first video there. Since then onward, it should be there. I can only say that it should be there because the past 3 years, 1 year screw up. As in system screw or something, I missed, I think, the first 2 lectures of video. So I can only say that it should be there.
So just one more thing. You said you would be confident in writing C/C++ program. Is that C and C++?
No, or. Yeah. Can do and, or include and.
Hi.
Yeah.
Being honest, like I've heard from the students that I know that this is just a little bit less hard than advanced operating systems, which is like the hardest subject. It seems.
See, it's just too kind. No.
How hard is it actually? Like, is this like most people fail this course?
No.
Or,
No.
like,
If you want the statistics, in fact, like I tell you, last year we had about 110 students, 5 students there.
oh wow, only 5 people fail. Oh really? I thought like 40-50%.
Yeah, but they're hard. As in hard in the sense of like, but
It's hard, but
if you do it hard, you wouldn't fail. Most students fail, right? As I said, to be honest, I can't guarantee that, but most students fail that really have some fundamental issues.
Right,
as I said.
okay.
It's not like they try hard and they fail. No.
oh okay.
So far, I haven't seen a single one in the past, I think, 3 or 5 years that they try hard and fail.
Oh okay. Oh
In
that's
fact, if they try really hard, they tend to have a high score rather than fail.
okay. That's good to know.
Yeah, but it's
So
not
it's like
easy.
I might not graduate if I take
No,
this
no,
time.
no.
Okay.
If you prepare to work hard,
Okay.
I don't think you will be.
How hard do you mean by work hard? Because some people at university that's 70 hours a week, and other people that's like 5. You know
No,
what I mean?
it's not that. I mean, when I say time management, when I ask the student, they hard because of like they underestimate and they only start like midway or like 1 week before the assignment due, then they screw up.
Right.
If you really start like not if I give you the assignment this week and you start next week or something, you should be fine. But if you start like maybe you just don't underestimate. I mean, if you overestimate, only like you panic, but you should be perfectly fine in terms of performance. I don't think so. I don't think you should.
How many hours per week do you reckon, outside of this 3 hours, how many hours a week do you reckon of someone of credit or to distinction roughly putting? Roughly. Like, are we talking 15 or?
What's your average performance on a programming course?
Mine, I did operating systems last year.
You did operating system last year?
Oh, sorry, last semester. And then I got like 60, which isn't that good.
But you passed, right?
Yeah.
Operating system, right?
Yeah.
Well,
That's pretty hard, but like,
Yeah.
how hard is this compared to operating systems?
Operating system, not advanced operating, just operating system, right?
Yeah.
I don't think it will be harder than operating system.
Really?
Yeah, I don't think it's different. It's different.
Right.
This way.
in
Operating
terms of time
system,
management.
they are more on the low-level programming, like
Yeah.
you deal with the buffer and stuff
Okay.
and so on. This one, they are more on the step, not the algorithm, not like those theory of the algorithm, but like how you do quick sort, like how you write it such that you can put it in a buffer. It's similar, but not as low level as operating system.
Okay.
Yeah. But my guess is based on if you have done operating systems, and many of them haven't even done operating systems, which is an advantage.
Okay.
Yeah.
Alright, maybe I'm not too bad. I've done like math 31411, so that's information code society, so some programming challenges. So like this, I should
So
be
guess
alright.
what? We are always trying to be helpful here.
Yeah.
If you do it
Okay,
and you
cool.
bump into some problem, you're
Alright.
willing to take it.
Maybe it's that person just, maybe it's just a few people that told me that this is just an impossible course. Okay. Thank you.
But that's a good point. I think after the break I should tell them when they say hard, like give them some statistics on the performance of the students.
Yeah.
Like how many got HD, how many got D, how many got credit.
Yeah.
Let me feel better.
Because it makes you sound like you're failing half the kids. That's my interpretation. Okay.
But it's a good question.
I have to go. I've got a job interview tomorrow morning. But
Good
yeah.
luck. Good luck.
Thank you.
My question is that I learned data structure 1 year back and I don't have link with data structures for now. So do I need to refresh it or?
No, as long as you know data structure, that should be fine. As in you have the knowledge of the data structure. that should be fine.
Okay. And how much mathematical knowledge we need for this subject?
No, it's not mathematical.
It's
More applied.
oh,
More applied than mathematical.
okay. Thank you very much.
So I try to enroll and it will be like you want to ask me for this.
I don't know. Because we are not serious at enrollment. They have to ask us anything to do with enrollment. You have to follow you to the school. Okay, guys. So one of you guys asked a very good question, although the guy who asked the question just left already. But I suppose I should still answer here again because just in case. So the question is very good. It's but also it's very open-end question. The question is, how hard is this subject? I mean, it's a valid question, but it's very hard to answer. As I said, if I tell you that, the answer hard is also, as I said before, is relative. Relative to me, I would say easy. And then he said that. But I heard from some student who done this subject before, and this is just slightly easier than advanced operating system. Now, I have a few comments there. Number one, is advanced operating system equal to hard? That's number one. Now, if you don't do it, or you haven't done it, or you decide you're never going to do it, then I suppose it's hard. But it's really my objective and a serious answer, not like joking kind of thing. Answer to that is like, I talked to some previous students before, and they agree to some certain extent. Some student, maybe around, I would say 1/4 of the student, they have done the advanced operating system. They will think that this subject is definitely easier than advanced operating system, but not by much. Now, then he asked me the second question. I said that, does it mean that this subject will fail half of the class? That's a very practical question. The answer is no, of course not. So, so I guess some statistics will help to answer the question better. Like, if you're saying the statistics from last year, we have about 110 students enrolled, and at the end, we have 100 students left in the class, means 10 students drop out. And out of the 100 students, we have about, in total, 5 students fail. So, of course, anyone can be that 5 students. So the number doesn't mean anything. I mean, there's always one person win the first prize of lottery. Just doesn't have to be you. So I'm saying that, like, number sometimes doesn't mean much, but that's the statistics. In fact, the course itself is hard because there's some hardcore concept there. Most students, they find that it's hard because this is not like when you're, I mean, that's not the official answer. That's me bring myself as Raymond, not the lecturer in charge, as a person. I talk to you. When you do the other subjects, I was a student before, when I was young, of course. When you're doing the subjects, you will find that there more or less some overlap between subjects. Some degree of overlap. You're learning basic programming. They probably teach you about sorting, for example. Then you do data structure. They teach you about sorting again. It's just a different aspect, maybe. So you feel good in a sense that, oh, I learned a little bit of that before. It's just different. Then when you do the courses that more or less have a similar context, you feel that it's easier. It doesn't mean that you will pass the subject, but you feel that it's easier. Now, when you walk into a subject talking about black hole you never seen before, you don't know what it is. The feeling you got is like, so hard, I never seen that before. But it doesn't mean that you'll fail that either. So a black hole will suck you in, of course, like this one. You probably get sucked in. but it doesn't mean that you will fail. You're full of mystery, that you're scared, you don't know what it is, but again, it doesn't have to be correlated with the outcome. So from the outcome point of view, I think we do have, it's a strange distribution in a sense that they are, not many people fail the subjects. As I said, it's always single digit. And those students who fail the subjects, usually they have disaster in the assignments or the exam. The disaster in the assignments, like they couldn't finish the assignment because of some difficulty. Now, we do have consultation. You can come to ask us about your difficulty, but it's either it's too far. That's why I said that you need to have the background. Either it's too far, it's very far. No matter how we help you, you won't be able to complete the assignment unless I type it for you. So that would be too far. Or you come for, asking for rescue too late. You are dying already. We try to pump you, you're still dying. That would be too late. So if you need help, first of all, come to grab help earlier. You save your time. And secondly, you also need to help yourself by grabbing some background yourself. Otherwise, some of the students, they really come to ask for help. I tell them like this and this. He didn't even understand what I said. So, but then the other people like surrounding, they understand. So clearly, I think, it can't be my problem then. Because there's some other students, like grab it, they run away. They were queuing up for consultation, but after that, they run away. Either they're too annoying or they already got what they want. So you can't be too far either. So if it's not one of the above two cases, you should be fine for this course. But as I said, you may need to pay more attention. Don't underestimate the material, that's all. Most of the students find that they underestimate it. That's why at the end they find it so hard. As in, they receive the assignment, I give you 4 weeks in advance, they start the assignment like 10 days before the deadline, or they warn you guys that, I usually will warn you though, like very good in warning you. So guys, if you start this week, you still have like 90% chance to finish the assignment. If you start next week, you'll be a miracle if you can finish the assignment. And if you don't listen, you want to challenge that, fine. That's your call, but you take the risk. So usually it's like that, then you probably will end up with one of those 5 people in the subject, but otherwise it shouldn't be. But your feeling, as I said, you will feel that the course is not easy. As I said, this is not the material that you've seen in the other subjects. They wouldn't. I hope that gives you more, because it's hard. It's hard to tell you how hard it is. It's hard to tell you that what it looks like when you're inside black hole, unless you go into it. But don't worry, when you go into it, it's too late. All right, then we continue. HTTP compression. So just now we talked about compression. This like gives you some glimpse what compression is like, what it looks like, what is compression. Where do you see them? You see them everywhere. For example, sometimes you browse some website, your browser will handle it, your web server will handle it, because we can set the gzip on to communicate between the content from the web server to the browser. So you can, in a HTTP header, most of the web server these days, they will enable the content encoding with the gzip on for the content. There are plenty of websites that they're selling stuff to do compression as well. For example, those websites, they're doing Java, they're doing ASP.NET, they're doing Ajax. All the streaming between the server and the web client will have the compression on to save the bandwidth and to increase like the performance of the web app and so on. So compression is usually behind the scene. You will have Opera, which is one of the mobile browser. There are many mobile browsers these days, including your Samsung Galaxy browser, which is done by one of the students graduated from UNSW. In fact, he was my student, Ryan. And he designed the Galaxy browser for most of the Samsung Galaxy devices. And about 3 years ago, Samsung Galaxy mobile browser do not have the compression in place. But right now, when you're using the Samsung Galaxy browser, it actually have the compression in place. So all the thing that between, there will be a proxy server sitting between the Galaxy browser and your browser. So all the web messages will go through the proxy server, compress it, and send to your browser. So you will actually receive the compressed information. And that is from, for web browsing. So behind the scene, you are just browsing web and so on. But actually behind it, it has been compressed. The compression is done before you know it. So it's hidden, but actually it's there. So there are lots of compression happen behind the scene. So if you look up all the Opera technology, Opera mobile and so on, they have lots of white paper and report telling us how they do the compression. There are lots of company. Storewise is one of the smaller ones, but there's a big one like IBM and EMC. So they're doing some, their dedicated box, for example, from IBM and EMC, they're doing real-time compression. Essentially in a cloud store, even a cloud store, on those cloud center, you have all the hard drive and storage. But to utilize those storage, they sometimes using hardware or software compression to compress the information before they store on the hard drive. Now again, those are transparent. You won't see the compression there. But the message, the information from where you use to actually store in the physical devices, it has been compressed. And when you use it, you'll decompress it. So those are the places that you will see compression. The Symantec is one of the companies that as in my research group, talked to like also more than 10 years ago. So, so antivirus, you will think that's not that much antivirus information. In fact, there's a lot. So these days, when you're doing Symantec and lots of antivirus updates, you'll find that, oh, they are downloading, they're installing, and they're decompressing. All the definition will be compressed. If not compressed, it can be up to 1 gigabyte. And you're not going to do every update is gigabyte. So that's why they compress it, but you will find that these days, we are paying more and more time to decompressing. So download is fast, but when it's installing, decompressing, it takes a while. Because when you have more efficiency in compression, it will take longer time to decompress it. It's a trade-off between space and time that you spend. And that's the trade-off of the technology. So this is where you will see compression is everywhere. You just maybe haven't paid attention to those the existing application of compression these days. So including software updates, these days all the software updates, registration files, UI schemas, definition, most of this definition these days, even the UI definition, if you're doing apps like iOS apps and so on, they're all in XML-like format. And they are getting bigger and bigger, and they'll be stored compressed. WebStream, RSS, Atom, JSON, during the transmission, they all compress.